Okay, Arnav, so let's initiate your this mock interview for IOCL. Arnav, very brief introduction from your side.
Okay, sir. As you've said, so my name is Arnav Adhikari, and I belong to Asansol, West Bengal, and I'm born and brought up in Guwahati, Assam. I did my schooling from Maharshi Vidya Mandir Public School from Guwahati, Assam, and I did a B.Tech in mechanical engineering from University of Engineering and Management located in Jaipur, Rajasthan, in the year 2018. My father is a retired railway service person and is an extremely perseverant person. And my mother is a homemaker and is a jolly and remains motivated. Yeah. And as a hobby, I actually keen into singing and actually prefer it while I am having tough times. And I'm a very friendly and amicable person. And currently I'm pursuing masters in computational mechanics from IIT Guwahati under the Department of Mechanical Engineering.
Okay. So Arnav, all the way from Asansol to Jaipur, why?
Yes, sir.
For B.Tech?
Yes, sir. Actually, I always wanted to do my bachelor's from a place where the place has some actually historical importance. So I didn't prefer to remain in the home city or hometown because I actually, my father used to work in railways. And so I had the experience of living in many cities throughout my basically span of 15 to 18 years. So I actually preferred that to move into or relocate into a better city for 4 years. So that is why I chose a better place. And Rajasthan or Jaipur is a very historically important city, as we know. And as a yeah.
When did you join your master's program?
2014, sir. The master's is 2021, sir.
21. Just now you joined, huh?
Yes, sir. Yes, sir.
किस department में आपने join किया?
Sir, I joined in computational mechanics under the Department of Mechanical Engineering.
Computational mechanics. So that looks like a good course.
Yes, sir.
So why you want to leave it now, Arnav?
Yeah, actually, since I just joined it recently, and it's just been a 1 month actually. And while after talking to the seniors, I actually came to know that the placement it does, but it's not, there is no surety of placement, first of all. Second of all, the package that they give is around 8 to 9 lakh and 7 to 8 lakh or around something like that on average. And IOCL on a better ground, it actually gives more package, and also it has a good remuneration and a good balanced stable life working with IOCL.
You're finding IOCL better option, right?
Yeah, obviously.
So ये जो आप सीट अभी आपका vacant हो जाएगा, उसका क्या करना है? जो सीट आप leave कर दोगे?
Yes, sir. Actually, as you've said, that I've also discussed it with one of my professor in the IIT itself, Professor Arup Nandi, and that sir has said that since there is also provision of inter admission, and also some of the MS students also come actually. So if basically an MTech student leaves, so there is no worry about that. They always have a lot of students that actually join. And since I just joined it for a month and didn't go for the entire course as of now, so it will not be a very big problem to the institute leaving that particular seat.
So Arnav, आपका कौन सा क्या तैयार? What have you prepared for your interview?
Yes, I prepared strength of material. I prepared fluid mechanics as of now, and yeah, a couple of topics on the fluid machines as well.
You are good with fluid machinery?
I'm not good. Yeah, I can try, sir.
मेरे को centrifugal pump और reciprocating pump में difference बताओ.
Okay, sir. In the centrifugal pump, actually, we employ the idea of the rotational, imparting rotational energy to the fluid, and that particular energy is further converted into pressure energy in the fluid. And in the reciprocating, actually, this is and yeah, another thing that happens in the centrifugal pump, the continuous. Hello, sir.
Go ahead.
Yes, sir. Yes, sir. In the centrifugal pump, the continuous flow of water takes place. And in case of reciprocating pump, it is actually in the class of.
Arnav, tell me why reciprocating compressors or pumps are called positive displacement devices.
Yes, sir. Positive displacement in the sense, basically, it compresses, like in the, I can say, in a closed domain. Basically, the compression takes place in the closed cylinder itself, and while the compression is taking place, there is no flow actually. It's taking place in a kind of closed system at that particular period of time. So that is
any
what,
idea what the pressure ratio in reciprocating or centrifugal?
Yeah, as far as I know, that in reciprocating pump, the pressure ratio is more, because we can compress it to a higher volume. So basically, the pressure ratio is around. I can, in a single compression, on an average, I think 20:1 or something like that I can do. In
Are you sure about this,
reciprocating.
or you're just guessing?
No. Actually, I have the rough value ideas, but yeah, I'm not very sure about it. But yeah,
Okay,
the rough,
just tell me where shall I use for reciprocating and where shall I go for centrifugal pump?
pump. Okay, yes, sir. In reciprocating and the centrifugal, I can say the reciprocating are actually used in household purposes also. Reciprocating pumps are used in household purposes also, and there are many applications as well. In the fridge, refrigerator, we use that is not pump actually, that is a compressor. But yeah, in the pump.
Have you heard about Tullu pump?
Yes, sir. Yes, sir.
कौन सा होता है?
That is centrifugal, I think.
Centrifugal, are you sure?
I'm just guessing.
टुल्लू पंप देखा तुमने घरों में?
Yes, sir.
पानी चढ़ाने के काम आता है.
हाँ सर, वो जब मैं दिल्ली में रहता था तो मैंने देखा, क्योंकि वहाँ पे कूलर ज्यादा यूज होता है, तो कूलर में बेसिकली टुल्लू पंप यूज होता है.
तो वो सेंट्रीफ्यूगल होगा क्या कूलर के अंदर? You want that much of discharge?
Oh no. Then
अच्छा, Arnab, now tell me, I give you 1 kilometer pipe.
Okay, sir.
उसमें oil flow करवाना है.
Okay, sir.
Diameter is also given. Oil का viscosity is also given.
Okay.
Tell me how to calculate the pump work required.
Okay, pump work. Yeah. Actually, pump work is calculated by the pressure difference we actually want to create. So at that particular, we also need to take care of the losses, because
if the pipe is uniform cross-section pipe, will there be pressure difference?
Obviously, there will be pressure difference, because you have said that the viscosity is there, so there will be losses itself. So obviously, there will be pressure difference.
So, कैसे निकालेंगे वो pressure difference?
Yes, sir. There is a formula actually that we have come across, that is FL V square by 2GT. It's this one for calculate Darcy wave equation. Yes, sir. So that particular formula actually would help us to calculate the losses, and that would actually create the pressure difference.
Okay, and from there, how to calculate the pump work?
Yeah, a pump work will be the pressure at the outlet minus the pressure at the inlet, and also taking into consideration the losses. So that will be the pump that will be the work that the pump has to provide. So
that is the only thing, or any other additional component?
Yeah, it will come if the basically delivery and suction also has a head, means height. Then at that particular point, we need to consider that also. Otherwise, it's we do not have to consider anything, sir.
Okay, Arnav, tell me, what do you understand by Reynolds number?
Reynolds number is the ratio of the inertia to viscous force, actually.
Okay.
So yeah, Reynolds number actually is calculated in many domains in order to see which force is dominant. Either the inertia force is dominant or a viscous force is dominant. Because if the viscous force is dominant, then it will be under the lower Reynolds number. So yeah, for that purpose, the flow will be laminar in that case, and otherwise transition or turbulent, depending upon the numbers. Right?
So if there is a river water flowing in the river, how shall you calculate the Reynolds number of the flow?
Yeah, that is rho v. I'll say. In the river, actually, I need to think of the characteristic dimension is basically a problem for me. Otherwise, the density is there, density of the water, and free stream velocity is also there. And yeah.
आपने internship कहाँ लिखवाया था अपना?
Oil India Limited, sir. Oil India Limited.
Oil India में किया था, कहाँ पे?
It's in the Guwahati, Assam.
What did you do in there?
Yeah. Actually, we were supposed to do a visual. We are not given any task as such, but we are there we had to learn what the work was taking place, how the work was taking place, and how the monitoring was taking place. And we
Did
also
you do some
actually
project there, Arnav?
no, actually not kind of project. The surveillance work they have said they have
That means
said to do.
monitoring, observation, and all. Huh?
Yes, sir. Yes, sir. Yes, sir. How the
आपने
work
हाथ
takes.
से कुछ नहीं किया?
No, sir. Actually, they didn't allow the.
How long it was there?
It was 15 days, sir. 15 to 16 days.
Only that much? Industrial training?
Yes, sir. No, actually, I tried to means request for a 30 days, but there was some something that was.
There must be some college requirement also, no? Minimum industrial training ka days ka.
College requirement as such, sir.
College must be asking you to go for industrial training of minimum 1 month or something, no?
Yes, sir. Actually, this says, but at that particular time, Oil India was going to do some actually renovation activity. So they said that they'll be able to provide for 15 days itself, 15 to 16 days. So that is the reason, sir.
Okay, Saglani, sir.
Okay, Arnav, what was your B.Tech project?
Yes, sir. I did the. I actually tried to. It was a group project actually, and we tried to assemble and make the refrigeration system with heating as well as cooling, and with a solenoid of a reversing valve was there.
So what was it all about? Can you very briefly tell me?
Okay, sir. Actually, we tried to develop.
What you wanted to do.
Yes, sir.
You mentioned that you made a refrigerator. So what was the purpose? And what was the end use?
Refrigeration system, sir. Yes, sir. Actually, we tried to do a heating as well as cooling refrigeration system using a reversing solenoid valve. And it was the actually we are trying to develop a live prototype of that. Since a lot of industries this is basically evolving and sector as of now. So we tried to make the solenoid and the casing and everything, and assemble it for a better efficiency.
Mm-hmm.
Yes, sir, that was what. Yes, sir.
So from where did you get the power for solenoid valve, for operating the solenoid valve?
What did I get, sir? Pardon?
From where did you get the power to run the solenoid valve?
Achha. Okay, sir. Yes, sir. The power was driven by the from the this itself power supply that was taken from the plug point, sir.
Mm-hmm. Okay, so how it is different from the normal refrigeration systems that you are having?
Yes, sir. So actually, in the normal refrigeration system, the it is actually designed for the normal cooling, only cooling purposes. But the all-weather AC, as we have
seen the ACs which are for heating as well as cooling purposes.
Yeah, that is what we tried to develop a live prototype. Actually, that is the thing.
No. What I'm saying is, have you seen in the market the ACs, all-weather ACs? I think you must have seen the ads also.
Yes, sir. Yes, sir.
All-weather ACs. So what is that?
Yes. Yeah, that is what we actually tried to develop a prototype.
How it is different? So that's what I'm saying. How your system is from those systems.
Yes, sir, I was trying to explain, sir. It is different in the fact that the cycle actually reverses with the help of the 4 solenoid valve. That actually does what it does is the evaporator and the condenser. The working of the evaporator and the condenser is reversed. Like in the normal refrigeration system, the evaporator is in the domain of the house, and the condenser is in.
What benefit do you get by doing this way? Like,
yes, I'll say. So actually, during in all other places where we have the extreme harsh conditions, like harsh in the sense the very hot or very cold conditions are there. So there people earlier used to have AC or cooler whatsoever, and a heat pump as well, because in the winters the temperature also used to reduce very low. So heat pump actually utilizes this heater. So the heater actually utilizes a lot of work energy, and it turns into the heat.
Okay.
But yes, sir.
Okay. Arnav, you told me that one of your favorite subject is SOM, strength of material also, right?
Yes, sir. So
have you ever heard about the pressure vessels?
Yes, sir.
Can you give me the name of a few pressure vessels in your home?
Yes, we have cylinders, sir, in the home. That's a pressure vessel. And Which cylinder, sir? LPG cylinder that we utilize in cooking, sir.
Any other examples?
Yes,
Outside
sir.
home?
Outside home. Outside home. There are some water tanks was there, those are that cannot be considered the thin pressure vessel, the thick. Yes, sir.
Okay.
Those are also kind of pressure.
Can you give me any particular application or an example?
Pardon, sir. Which application?
In automotives.
Can you
give me any example or
of pressure vessel?
Pressure vessels, right?
Yes, sir. Yes, sir. Yeah, in the automotive also. Sometimes they have NOx cylinder, like there it can act as a pressure vessel. CNG gas, because today this era is actually turning into CNG cylinders. Those are pressure vessels. So,
okay, so what kind of pressure vessel is it? Thin or thick?
Yeah, we can consider in the thin section depending on the diameter to thickness ratio.
Okay, can you draw the Mohr circle for this?
Yes, sir. I'll try. Yes.
For the state of stress in this kind of vessel.
Yes, sir. Yes.
Okay, go ahead.
So, try to show actually. So is it visible, sir?
No, I'm saying Mohr circle. Mohr circle.
Oh, so sorry. I actually, sorry, sir. I draw the state of stress. This is, I think.
So let us say, okay,
yes.
let us say because of very high pressure, this particular vessel fails. Can you let me know in which particular stress and in which particular plane it is going to fail?
Okay. Yes, sir. I'll say. So, since we actually design that particular pressure vessel so that it's a ductile material, so I think it will fail in shear actually. So since ductile material are weak in shear, so it will try to fail in the plane of maximum shear stress actually. Yes, sir.
Where is that?
Yeah, that is okay. That's that's a plane which is at a 45 degree from like not 45 degree. I need to actually calculate in that particular condition. I need to calculate the basically angle depending on the state of stress, because PD by 40 is one normal stress and another principal stress, another principal is PD by 2T. I need to calculate the maximum shear stress, and in the Mohr circle I can show the plane. Otherwise, I need to calculate the particular degree, sir.
So, can't you tell me the exact location of the plane?
Sir, for the exact location, I need to calculate, sir. Actually, for the theta.
Can't tell from the Mohr circle.
Yeah, I can tell from the Mohr circle, sir. Yes, sir. From the Mohr. Okay, sir.
No, just look at the Mohr circle and tell me.
Okay. I'll just have to say. Okay, the plane that is basically perpendicular. I mean, that is 90 degree from the plane of the this one. No, 90 degree. 45 degree.
Okay, Arnab, do you know the beam of uniform strength? Have you heard the term beam of uniform strength?
Yes, sir.
What is it?
Actually, we tried to design a beam that has a constant or uniform stress throughout the beam, and stress developing throughout the beam. So that is the beam of uniform strength, and that particular stress resembles with the maximum stress in the beam, sir.
Can you give me a few examples for that?
Okay.
Some of the applications where this we can utilize this concept of beam of uniform strength.
Okay. Practical examples, as if not, it's not striking my mind, sir. So we can also design in some cantilever beam where we actually want uniform stress so that no part actually has a tendency to fail.
I'm talking about the application. Where have you found it? Have you ever seen it? Such
No,
kind
no,
of
no.
configuration, have you ever seen it?
Yeah, I've seen it, but yeah, I couldn't recall, sir. I just in the.
Okay, what is the use of doing that way? Like, why you normally make it a beam of uniform strength and all that?
That's the use is that it doesn't has any particular weak section because the same stress is acting from at any particular cross section throughout the beam. So weak section doesn't stay. So that is the actual.
But then it is the same case even if it is you are keeping it as a beam of uniform cross section. That time also it is going to have the same thing. You're saying that it is going to have the this safe. You want to keep it safe.
Yes, sir. But when we are keeping it of a same thickness, then it does not ensure of same stress acting at every cross section. No, sir.
No.
So
that is what I am saying. What is the benefit of having making the same value of the stress at every section? That is my question.
Yeah, the benefit is when the basically thickness is kept same, then the stress, some particular section has more stress acting and some particular section will have a less stress acting. So the section that where the more stress is acting, that particular section has a tendency of failure before the other sections. So that is the basically primary reason I can conceive that beam of uniform strength is preferred, sir.
Okay, so Arnav, why you're interested in IOCL only? Why not in any?
So your voice is cutting, sir. Can you just repeat, sir?
Okay, let me just repeat my question.
Yes, sir.
Have you received any call from other PSUs?
No, sir. No, sir.
Okay, so why you're interested only in IOCL?
So because there are a couple of reasons why I'm interested into IOCL, because IOCL is the, first of all, it's the most good, I mean, the best employer, first of all, and it provides stability in life and job as well. It provides good remuneration, and it's the largest Maharatna and the.
Okay. So what role do you see for yourself in IOCL?
Yeah, once if at all I get a chance to work with IOCL, then obviously I see myself in a very good stable position where I can find myself helpful to other employees and also can
okay, let's say if you're posted in the sales department, let's say if you are given if you're posted in the sales department, the IOCL,
yes, sir,
will you be okay for that?
Yes, sir. I'll be okay with that because I'm okay with any domain, sir.
But where then all that you have technical knowledge that you have gained?
Yes, sir, I know that. Sir? Yes, I know that because in the sales also we need to because in every domain we need to have some or other knowledge of the other domains as well. Being in the sale doesn't mean that I will actually in the sale domain. We also have to learn the intricacies of the what is actually the company is doing. So I'll have a better knowledge of technicalities and I'll be able to explain to someone whom I will be able to sell it. So I think it will be a addition, a plus point for me. And also since I actually try hard on my communication skill as well. So I think that it will be a good, it will be an addition for me because I will have the technical knowledge and also I'll push myself in the sales domain also.
Okay, so I think now we can give him the feedback.
Yes.
Okay, so अर्नब पहली बात तो ये कि आपका जो बीटेक प्रोजेक्ट के ऊपर मैं जैसे ही जंप किया आप नर्वस हो गए.
हाँ वो तो एक्चुअली प्रिपेयर नहीं थे सर.
You are not able to explain. जो मैं जाना एक लेमैन की तरह अगर आप एक्सप्लेन करोगे मतलब दैट मींस अगर कोई लेमैन पूछता है आपसे क्या किया है आपने वही नहीं बता पा रहे हो आप कि किया क्या है और हाउ इट इज गोइंग टू बी डिफरेंट.
Okay, sir.
Even though let's say आप बना नहीं पाए पूरा या आप let's say but एक kind of जिस डायरेक्शन में आपने एक वर्क किया उसकी वो तो पता लगना चाहिए this is the benefit that you are going to have.
Okay, sir. मैं काम करूंगा उस पे सर.
Clarity लाओ किया क्या है what you have done and what could be the possible benefits क्या हो सकते हैं. ऐसा नहीं है कि आप रिप्लेस कर रहे हो करंट सिस्टम को बट देयर इज अ वे कि इस डायरेक्शन में, दिस इज वन वे कि हम उसको इंप्रूव कर सकते हैं, या दिस कुड बी द वन पॉसिबिलिटी दैट
ओके
यू हैव
सर।
टू टेल, राइट?
यस सर।
तो
यस।
प्रोजेक्ट के बारे में वो पूछेंगे आपसे
हाँ सर।
डेफिनेटली,
हाँ हाँ।
ठीक है? उसको गो करो ढंग से, और यू मस्ट बी एबल टू जस्टिफाई कि आपने कुछ अच्छा काम किया है, एंड व्हाट वाज योर रोल, आपका
ओके
स्पेसिफिक
सर।
रोल उस प्रोजेक्ट में क्या था, क्या किया आपने? आपने कहा ग्रुप
ठीक।
में किया, पर ग्रुप में आपका रोल क्या था, दैट इज मोर स्पेसिफिक,
ओके सर।
ठीक है? तो आपकी कंट्रीब्यूशन क्या रही, दैट इज गोइंग टू बी द मेजर पार्ट ओवर देयर। एंड देन मैंने आपसे टेक्निकल क्वेश्चन पूछे, फॉर एग्जांपल प्रेशर वेसल के आपने कहा एलएनजी, ओके ठीक है, सीएनजी और एलपीजी आपने बता दिया। देन जब मैंने आपको मोर सर्कल ड्रॉ करने के लिए कहा, मैंने कहा ये बताओ कि कहाँ फेल हुआ, आपने बोला ये शेयर में फेल हुआ।
अगर
फिर
डक्टाइल
डक्टाइल मटेरियल शेयर में फेल हुआ, और वेयर इज द प्लेन ऑफ मैक्सिमम शियर स्ट्रेस?
सर वो मतलब 45 डिग्री में तो तब होता है ना जब
ये तो
बेसिकली।
मोर सर्कल देखते हो, इज वेरी प्रीटी इजी, आप मोर सर्कल
हेलो हेलो।
कब, तो अब बताओ जरा, आपने जो मोर सर्कल ड्रॉ किया, टेल मी वेयर इज द मैक्सिमम।
सर
Yes
सर
or no?
एक्चुअली सर वीडियो सर
Yes.
पॉज हो गया। सर आप एक बार और सब बता सकते हैं, एक्चुअली वीडियो पॉज हो गया था सर।
ओके,
हाँ
मेरा
सर।
क्वेश्चन ये है कि आपने मोर सर्कल ड्रॉ किया है ना,
हाँ सर। हाँ सर।
तो कहाँ पर है, वेयर इज द मैक्सिमम शियर स्ट्रेस?
सर बेसिकली वो मतलब वर्टिकल होता है जो अब वो
वर्टिकल क्या
90।
मतलब, वर्टिकल का मतलब क्या, व्हाट इज द मीनिंग ऑफ वर्टिकल?
हाँ
कहीं
वो
से तो
उस
लिया होगा रेफरेंस।
हाँ हाँ वो बेसिकली वो जो जिस प्लेन पे PD/40 मतलब जो लॉन्गिट्यूडनल
कौन
स्ट्रेस लग रहा है।
सी है वो, आपने बोला नॉर्मल स्ट्रेस है ना, प्रिंसिपल स्ट्रेस है, तो एक्स एक्सिस पे आपने प्रिंसिपल स्ट्रेस शो की है, तो
हाँ
उस
हाँ
जिस प्लेन के ऊपर आपका जो है नॉर्मल स्ट्रेस एक्ट कर रही है, उससे 45 डिग्री पे चले जाओ एक्चुअल।
हाँ हाँ। लेकिन
तो
वो 45 हमेशा थोड़ी होता है, मुझे नहीं पता सर, एक्चुअली ये मुझे शायद रिवाइज करना पड़ेगा।
देखो ना, आपने हमेशा नहीं होता, पर मैक्सिमम वी आर टॉकिंग अबाउट द प्लेन ऑफ मैक्सिमम शियर स्ट्रेस। तो जो आपने ड्रॉ किया देखो उसमें कहां पर आ रहा है, वो 90
हाँ
डिग्री पे आ
वो
रहा है ना मोर सर्कल,
हाँ 90 हाँ, तो हाँ डिवाइडेड बाय 2 होगा, 45 में आएगा।
45 ही होगा, और क्या होगा?
हाँ हाँ।
तो मुझे ऐसा लगा कि आप उसको कोरिलेट नहीं कर पा रहे, मोर सर्कल जो ड्रॉ कर रहे हो और उसकी अंडरस्टैंडिंग, दे आर नॉट मैचिंग।
ओके सर।
सेम वे बीम ऑफ यूनिफॉर्म स्ट्रेंथ आपने जब मैंने पूछा, वो तो बता दिया आपने थ्योरेटिकली, फायदा क्या है?
हेलो।
पता होना चाहिए,
हाँ सर।
राइट? जैसे कैंटिलीवर है, कैंटिलीवर आपका फिक्स एंड पे जो है मैक्सिमम स्ट्रेस होगी, तो व्हाटएवर
हाँ
द जो क्रॉस सेक्शन एरिया आपको फिक्स एंड पे चाहिए, उतना ही क्रॉस सेक्शन एरिया आपको जो कहीं मिडिल या फ्री एंड की तरफ तो नहीं चाहिए, यू डोंट नीड दैट मच बिकॉज़ द
हाँ
वैल्यू
हाँ
ऑफ स्ट्रेस विल बी लेस। तो
हाँ
कम
हाँ
कर
हाँ।
दोगे अननेसेसरली, उतना ही क्रॉस सेक्शन एरिया थ्रू आउट रखोगे तो क्या होगा, मिडिल में।
तो उससे सर फायदा क्या है
दैट इज द
बेसिकली
बेनिफिट दैट यू गेट।
सर?
तो यही तो
बेस
फायदा है आपका। मान लिया मैंने कहा कि फिक्स एंड पे उस वैल्यू ऑफ फोर्स को या बेंडिंग मोमेंट को कैरी करने के लिए आपको 10 mm स्क्वायर का एरिया चाहिए क्रॉस सेक्शन। तो
हाँ हाँ
अगर मैं 10 mm क्रॉस सेक्शन एरिया ही कैरी कर बनाता हूं थ्रू आउट,
हाँ हाँ
एक केस होगा ये।
हाँ
दूसरा केस होगा कि मैंने किया क्रॉस सेक्शन एरिया रिड्यूस करता गया, क्योंकि मुझे पता है
हाँ।
कि स्ट्रेस वैल्यू कम होती क्या
कम
कहते
होते
हैं,
जा रही है।
कम
हाँ।
होती जाएगी, तो मैं एरिया रिक्वायर्ड टू कैरी दैट स्ट्रेस आल्सो विल डिक्रीज।
यस यस।
रिक्वायरमेंट कम है तो मैं 10 नहीं क्यों रखूं? अगर यहाँ पर मेरे मिडिल में मेरा 5 mm स्क्वायर से काम चल जाता तो आई शुड कीप द 5।
मतलब वो मटेरियल थोड़ा सा कम लगेगा, यही बेनिफिट है ना सर?
ऑब्वियसली
हाँ।
टेपर कर दिया आपने, मिडिल कम हो गया तो मिडिल सेविंग है ना आपकी। यू मस्ट
हम्म।
हैव सीन द क्या बोलते हैं उसको, लीफ स्प्रिंग। गाड़ियों में देखें, कार के
हाँ
पीछे
हाँ
जो
हाँ
है
हाँ
अगर,
हाँ
या
हाँ हाँ
ट्रक में आपको साफ ही दिखते हैं लीफ स्प्रिंग, किस लिए बनाया
हाँ
होता है
हाँ हाँ।
कैंटिलीवर उस तरह का? ग्रेजुएटेड लीव्स क्यों होते हैं? पूरे ही रख लेते हैं आप शुरू से ही।
अच्छा 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 अच्छा।
दे आर एक्टिंग लाइक ए कैंटिलीवर। कैंटिलीवर तो आपको पता है मैक्सिमम स्ट्रेस कहाँ होगी, फिक्स एंड पे जहां पर सपोर्ट मिल रही
फिक्स
है
एंड पे
आपको,
जहाँ पे सपोर्ट है। हाँ।
ठीक है? तो ट्राई टू कोरिलेट द कंसेप्ट, आप बोल रहे हो बट कोरिलेट नहीं कर पा रहे हो चीजों को कंसेप्चुअली। तो
ठीक है सर।
आपको वो रिलेटिवली सिंपल क्वेश्चन पूछेगा IUCL में, बट यू मस्ट बी एबल टू मतलब उसको अच्छे से एक्सप्लेन करने की पोजीशन होनी चाहिए।
ठीक है सर। ओके सर। हेलो।
ओके, ओवर टू डॉक्टर विजेंद्र।
Okay, so Arnab,
यस सर।
see, fluid machinery is a very important subject.
हाँ सर।
और मेरे को लगता नहीं तुमने रिवाइज वगैरह किया है, थोड़ा पढ़ो।
नहीं एक्चुअली बहुत जल्दी किया था एक्चुअली सर।
और ब्लफ नहीं मारना, इफ यू डोंट नो समथिंग डोंट ब्लफ।
ओके सर।
इनकार कर दो, अगर श्योर नहीं है ना तो इनकार कर दो, क्योंकि अदरवाइज ब्लफ में काउंट हो जाएगा। जैसे प्रेशर
ओके सर।
रेशियो कितना है, अगर पता नहीं है तो ब्लफ नहीं मारो। आप ये
ओके
बोल दो कि सर मेरे को आइडिया नहीं है इसका। और फ्लूइड मशीनरी पढ़ लो, फ्लूइड मैकेनिक्स इज अ वेरी इंपॉर्टेंट सब्जेक्ट फॉर IUCL.
Okay, sir.
Losses, fluid mechanics में भी let me tell you the losses, Darcy equation and pipe losses and fluid machinery pumping, तो ये चीज में से ज्यादा क्वेश्चन पूछता है वो, राइट?
Okay,
बिकॉज IUCL पाइपिंग्स में भी है ना, तो
हाँ सर.
उसका पंप वर्क कैसे निकालना है, रेसिप्रोकेटिंग पंप, सेंट्रीफ्यूगल पंप, कंप्रेसर और पंप में डिफरेंस क्या है, नेट पॉजिटिव सक्शन हेड कितना होता है, डार्सी
अच्छा.
इक्वेशन कैसे लगानी है, और डार्सी इक्वेशन गैस पे लगती है कि नहीं लगती है, ऑयल पे लगती है पर गैस पे लगती है, तो गैस को अगर पाइपलाइन में हम सप्लाई कर रहे हैं तो गैस
हाँ.
में कंप्रेसर वर्क कैसे निकालेंगे हम, ये क्वेश्चन पे थोड़ा वर्कआउट करो अर्नब.
ओके सर. ओके सर.
तुम्हारा हुआ है मॉक, बाकी बच्चों का भी मॉक हो रहा है, वो भी सुनना,
Okay,
राइट?
ठीक है सर.
चलो,
सर वो
all the very best
बेसिकली
and prepare
पैनल
for
में
it.
अवेलेबल हो जाएगा ना?
हाँ, ये पैनल में आ जाएगा, पैनल में यूट्यूब पे कहीं ना कहीं तो आ ही जाएगा,
ओके. ओके सर.
राइट? और
ठीक है सर.
उसको आप तैयारी करो अच्छे तरीके से.
ओके सर. थैंक यू सर.
ऑल द बेस्ट अर्नब, थैंक यू.
ओके सर. थैंक यू सर.